This is AP Chemistry 3.11, 2 examples of balancing redox reactions. I'd recommend you just watch these and save solving it on your own until you've seen a couple more examples, since these can be a little bit tedious. All right, here's the first example. It says, write a balanced ionic equation to represent the oxidation of iodide by permanganate. Those are the two reactants to yield molecular iodine and manganese 4 oxide. So what we do is we start with writing the two half reactions. Iodide turns into iodine. Permanganate ion turns into manganese 4 oxide. So those are your two half reactions. Then balance everything. In other words, iodine and manganese. We'll do the oxygens then by adding water molecules. So since we only have two iodines on the product side, but one only on the reactant side, we need to double that. That's fine. It's balanced with respect to iodine. We then need to, manganese looks fine, but oxygen does not. It's time for the oxygens. So we'll balance that by adding two water molecules. We then balance hydrogen by adding 4 H pluses, right? Everyone hates. It's time for electrons, and we are -2 on this side. We'll balance it by adding 2 electrons on the product side. We were +3 on this side and 0 on that side. See the 4 plus and the -1. So we add 3 electrons to that side to make both sides 0. Now we have to balance electrons overall, since when we combine these, we would have 3 electrons on this side and 2 on that side. The common multiple is 6, so we'll triple this entire half reaction and double that entire half reaction. Is there a last step? There is, because it says it's under basic conditions. So notice that we have, let's see, we have 8 H pluses on that side, so we add 8 OH minuses to each side. 8 H on that side and 8 OH on that side. That obviously won't change the balancing, since we're adding exactly the same thing to both sides, but it will make the conditions basic rather than acidic. It's combo time. Notice that it's important what's in parentheses and what is not, so carefully add it. And let's see, we should have 6 I minuses, right? And I'm going to work my way down. We have 8 OH minuses and 8 H pluses, so we could save a step by simply adding 8 waters there. The electrons did cancel. We have 2 permanganates. And on the product side, we have 3 iodines. Electrons already canceled. We have 2 permanganates. We have 4 waters. And we have, it's outside of the parentheses, 8 OH minuses. Write them all down. And cross your fingers that it all balanced. If it didn't, it's usually best to erase the whole darn thing and start over. Let's check one random thing. Oxygen's usually the most challenging. Are we balanced with respect to oxygen? 4 oxygens plus 8 oxygens makes 12. Do we have 12 oxygens on the product side? We have 4. See how it's 2 pairs plus the 8. We do have 12 oxygens. You'll see that this entire thing is balanced. A possible overall reaction, we'll just add some random spectator ion to anything that's charged, and everything is negative. So what if we just added potassium, for example? A possible reaction could be potassium permanganate and potassium iodide and water forms manganese 4 oxide plus molecular iodine plus potassium hydroxide. Okay, now let's do another. The reaction between permanganate ion and oxalate ion in acidic solution produces manganese ion and CO2 gas. So the half reactions are, once again, pretty easy to find. Permanganate turns into Mn2+, oxalate turns into CO2. Let's write that down. And let's go off to the races. I'm not going to use the mnemonic, but I'll see if we can just walk our way along. We better add another carbon to balance carbon. We better add, no, manganese is fine, so it's time for the oxygens. 4 oxygens, 4 oxygens. See the 2 pairs? I think we're fine up here. But 4 oxygens, we need 4 water molecules added to the product side. That gives us 8 H pluses on the reactant side. And everyone hates its electron time. 2 minus and 0. So let's add 2 minus to the product side. 7 plus and 2 plus. let's add 5 electrons to the reactant side. One thing I do sometimes is I add electrons to the wrong side, thinking it balanced out. So be careful when you do that. Okay, so we have 2 electrons on this side, 5 on that side. We need to multiply this entire thing by 5, that entire thing by 2, since the common multiple is 10. That's balancing out our electrons overall. And there it is. Okay, fine. And it is in acidic solution. We already have our acid, so I believe it's adding time. Notice by keeping the arrows lined up, it helps you to add up each side. So let's do the reactant side. 5 oxalates. That canceled. 10 H pluses. No, 16 H pluses. See, 2 times 8. 2 permanganates will form 10 carbon dioxide. That was canceled. 2 Mn2 pluses and 8 H2Os. Check something to see that it all balanced. I think I'll lazily just do permanganate. There's 2 on each side. You can balance everything. 10 carbons, 10 carbons. Charge should work out. And this is our net ionic equation balanced for that. So that's 2 examples of balancing redox using the half reaction method.